Hello everyone, welcome to this session on Naive Bayes Text Classifier. Myself Vani KS, working as an assistant professor at Department of ISC in MIT. So before we start the Naive Bayes Text Classification, let us see some basics about this Bayes Theorem. Naive Bayes classification algorithm is actually based on the Bayes Theorem, which is a mathematical and a statistical algorithm, we can tell. This was primitively developed by an English statistician and a mathematician called as Thomas Bayes. This Bayes theorem usually uses the conditional probabilities to predict the outcome of later probabilities. In the sense, it's based on the conditional probability. Given some condition, it calculates the probability, and these prior probability and condition probability will be used to calculate the posterior probability. And the naive Bayes text classifier is purely based on this conditional probability and the prior probabilities. Coming to the naive Bayes text classification, actually, this is one of a classification algorithm which comes under supervised machine learning algorithms. And this has proven that it is work better than decision tree classifier and the neural network learning and any other classification algorithms it is. So what is the basic understanding of this naive Bayes text classifier it is? So given any new instance, something like represented by these attributes called as A1, A2, A, and so on. Like for examples, like 5 attributes we have, 5 features we have, or 10 features we have, which is represented by A1 to AN. So given these features called as A1 to AN, how the target value of the given instance will be predicted based on this formula called as probability of Vj, Vj belonging to V, where Vj can take off the any of the class labels, in the sense the target values. The target value from the capital V can be yes or no. The target values from the capital V can be spam or not spam, something like that. So the posterior probability of a label called as Vj, any of the target label, given these attributes called as A1 to AN. So any of these attributes in the sense of an instance can be taken, and then the probability of a target label can be calculated. So this here what happens, it is we have used the VMAP. VMAP is nothing but maximum A posterior probability. The meaning it is whichever VJ, whichever target label has the highest probability, that is called as VMAP, and that label, the label with highest probability, will be assigned to this new instance with these attributes. So that's the meaning of this formula here, the mathematical equation for naive Bayes text classifier. So if we use the Bayes theorem, which I told you in the previous slide, to write the Bayes theorem or the naive Bayes text classifier, it is nothing but the same formula has been expanded in the Bayes theorem, where the numerator is having probability of all the attributes given Vj into prior probability. That's nothing but probability of Vj divided by probability of all the attributes A1 to AN. In the next step, you can see that the denominator is neglected. The probability of all the attributes together is neglected because this is a term which is independent of this Vj belonging to V. So that's the reason the denominator has been neglected here. So it is ultimately the product of these two terms here which has been calculated. So whichever label Vj from the set called as V has the highest probability, that will be called as VMAP, and that will be the label which will be assigned to the new instance for which we are expecting the classification to be done. So that again, it is coming back from the previous slide, whatever I told, it is that the same formula here, it is written as naive Bayes text classifier is written as the posterior probability of Vj into product of all. And here the assumption is naive Bayes text classifier, the assumption is every attribute is independent of each other. In the sense, the first attribute, first feature, and the second feature doesn't have any relation in between, or maybe any other feature. The all the attributes are independent of each other, it is. So that's the basic assumption in naive Bayes text classifier, it is, where this assumption is not there. We're coming to the next algorithm, which is called as BBN, Bayesian belief network. We have an assumption that some of the attributes or some of the features are dependent on each other, but here they are independent. So that is why whatever the previous formula we had, it is written as the product of all the attributes. It is the probability of an attribute given label into the product symbol into the probability of the next attribute given the label, like that. So product of all the attributes given a particular label. So that is the formula here for naive Bayes text classifier. Yeah, coming to the text classification, why I took this text classification, because naive Bayes text classifier works very good on the text document. So there are many versions of naive Bayes text classifier, like multinomial naive Bayes, Bernoulli naive Bayes is there, Gaussian naive Bayes is there, and most of the naive Bayes algorithm works very good for text classification. So I thought that let me explain the naive Bayes classifier with the text classification, or maybe classification for a text it is. So what is text classification actually? Assigning labels to the document based on their content. So based on the paragraph, based on the word it is, what type of text it is, assigning some labels to the documents. We call it as text classification. So some of the examples of text classification, or some of the examples of text classification, or maybe it is considering it as what type of mail it is, whether they are spam mails or the ham mails, or maybe they are the priority mails, which is very top priority, or maybe what type of language they are. Given a document, what type of language that document is having, maybe English, French, or Spanish, or maybe given a document, what is the sentiment within that document, or maybe it is given a document, what type of document it is, whether it belongs to politics, business, technology, or something like that. So these are some of the examples of text classification. So let us take this example for the text classification, where this is a small data set which we are having. The first one, which is comma separated, again it is. The first one is the sentence, the text what we are having. I love the sandwich. And the second, after a comma, is about what type of statement it is. It's a positive comment it is. Coming to here, the sixth statement, I do not like this restaurant. This is a text given. What type of text it is? It's a negative statement, negative sentiment it is. So like that, there are some 18 statements here, and after every statement, there are some labels given, sentiments of that labels given. So coming to the naive Bayes text classification, how it can be done. So there is some coding here done. Along with this coding, I'll try to explain the naive Bayes text classifier. So initially, we have read the data set here, which we are reading it here, the same data set what I showed you in the previous slide. We are reading it using the pandas library called as pandas.read CSV, where this is a text file we are passing, and these are the column names what we submit. So this is nothing but the reading of a data set it is. Later, we map all the positive, because of ultimately all the machine learning algorithms require in the sense they work with some numbers. They require the numbers for doing some machine learning training or something. So that is the first step here what we are doing. The positive labels have been converted as 1, has been encoded as 1, and the negative labels have been encoded as 0. So that is what the labels we are done. Again, in the next slide, we'll see that even the messages what we are having will be converted ultimately into numbers. So this is the first step what we did, the pre-processing. The labels in the document have been converted into 1 and 0, positive for 1, negative for 0. So the next one, we are splitting the data set into two parts, train and test. Using the sklearn machine learning library and the model selection sublibrary, we are using this function called as train, test, and split to split that 18-row data set into two parts, training and testing. So we are passing that x and y here. X is nothing but the statements what we had. Y is nothing but all the labels which we extracted here from the statement. So the train, test, and split returns 4 arrays called as x train and x test, sentiments and the label, y train and y test, sentiments and the label. In the sense, out of 18, we are keeping some of the statements for training, some of the statements for testing, some of the y labels and y labels for training and testing as usual. So as we are not passing any parameter to train, test, and split function, by default, the split will be done as 75-25. In the sense, out of the 18 rows what we had it, when I don't give any parameter there, by default 75-25 will be taken. So 75 out of 18 is 13, which is a training shape or the training size. 25% of the 18 rows is about 5 rows, which is taken for testing. So this is the split what we did it from the previous slide. 75-25 ratio. We have divided the data set, split the data set into training and testing parts. We can also pass explicitly the parameter, something like 80-20, 90-20, 10 is also allowed. But the ground rule is keep more for training, less for testing. Yeah. So this is about the bag of words processing or the feature extraction. As I told, we converted the labels into 1 and 0. We converted the labels into numbers. Similarly, we have to also convert our texts what we have, the message what we have into numbers. Because ultimately the naive Bayes, the Gaussian naive Bayes or the multinomial naive Bayes requires our input should be in terms of numbers. So for that, what are the series of steps we have to follow? So this is called as feature extraction, what we are doing. The first step will be tokenization, in the sense that document will be split into n number of words. It will be split into words depending on the comma or whatever the comma separators are there in between, dot, in the sense full stops, comma, semicolons, everything have been removed. All the entire document is divided into certain words. And then the second step is vocabulary building. Given that entire word of words what from the entire document it is, we remove the duplicate words, we remove the stop words, everything, and we start building the vocabulary, in the sense the important words in the document. Usually the procedure done will be in such a way that the stop words, the conjunctions, or maybe the prepositions, the articles, everything will be removed, and then the vocabulary of words, unique words in the entire document will be prepared. And the third step is, as I told, converting our text to document into a frequency encoding, or converting our text to document into numbers, where we write the frequency of each word and we prepare a matrix, sparse matrix numbers input for our naive Bayes. How do we do this entire steps? Let us see. This is done using a function called as count vectorizer from the sklearn feature extraction. So sklearn is having some library called as feature extraction. From that library, we are using this function called as count vectorizer, which does all the steps whatever I told. Suppose example it is, if I take these 4 statements in an array, these are the 4 statements which I need that. Let us see how the frequency table will be constructed by using the count vectorizer. So what I told you it is, these are the statements what we have, the documents what we have. From this entire 4 statements, the unique word has been extracted here. They have arranged in alphabetical order. The sense we have, this is called as bag of words, this is called as vocabulary. All the unique words from the 4 statements have been taken. The words have arranged in alphabetical order. What is the first row in this table here? How many times each word has occurred? This is the column headings are nothing but the features. The column headings are our features for our machine learning now, for our naive Bayes text classification. So how this matrix is built, how this table is built, take this first document. In that first document, how many times each word is occurring? As you see, the first document and has not occurred. So this is a sparse matrix what I told. So what we'll do, we only store the non-zero values. Zero values will be usually ignored. We are not storing it. So this is a sparse matrix it is. And in the first statement, document has occurred once. You can see it here. Document has occurred once. First has occurred once. Is has occurred. One and second are not there. The has occurred once. This has occurred once. Coming to the second statement, it is document has occurred twice. Here it is. This is the first occurrence and this is the second occurrence. So document has occurred twice. So like this, we prepare the matrix. We prepare the sparse matrix. So given this sparse matrix, which will be done using the count vectorizer, as I told, vocabulary building, the sparse matrix generation is nothing but the frequency generation. Everything will be done by this algorithm in sklearn called as count vectorizer. So this is the bag of words what I told. This is the frequency what will be constructed usually. This is called as a bag of words representation. So once we do that, the bag of words, we are converting it into an tabular representation. In a sense, we are converting it to an array by using the pd.data parameters. because we need to have a data frame object. It is called as document term matrix, which I already stored that it's a sparse matrix. It only stores the non-zero values. Okay, so coming to the next step, it is we have read the data set, we have pre-processed it by converting the text to numbers. Maybe it is labels processing or maybe it is the text processing. We have done it using count vectorizer. Finally, about applying the naive Bayes text classifier, we are using an algorithm here called as multinomial naive Bayes. Multinomial naive Bayes works very good for text documents. As I told, there are many other versions of naive Bayes. So to this multinomial naive Bayes, we are passing that DTM, what we did it in the last slide, the frequency table, what we constructed, and the Y train where values, which are nothing but are the positive and negative labels decoded. After that, we are as usually predicting the labels for our text documents. And you can see, I think for predicting, we don't pass the Y test, we just pass the X test here and check what is the Y test, what we get it. Finally, we compare the Y-test values with the predicted values to check how much is our accuracy of this entire machine learning. The formula for naive Bayes or the multinomial is nothing but what is the probability of a label given all the features is nothing but this is the Bayes theorem again it is. Probability of features given label, probability of a label, prior probability given by probability of all the features. So once we do this, this is another example which is taken at us. Once we do this formula at us, we get something like this, the probabilities. Something like this, the posterior probability. What is the probability of a document D7 belonging to auto label? What is the probability of a document D7 belong to sports category or something like this? So out of the three probabilities, you can see that this is not normalized actually. That is why the probability values are very less here. So out of so many probabilities, you can see, I think here, this probability is little higher compared to the other two probabilities. So what I'll tell, I assign the D7 document a label called as auto, in the sense the D7 document belongs to a type of document, category of document called as auto category. So that is what we have done it here. So finally, D7, which is a text document, new text document, has been assigned out of three labels, auto, sports, and computers. So that was the positive and negative, what I told you in the initial one, assigning positive, negative sentiments to any text document. This is another example what we took. Depending on the words in the document, we classify the document either belonging to a sports documents, computers document, or auto document. So these are the other two examples what I took for naive Bayes text classifier. Ultimately, I would like to tell that applying the naive Bayes text classifier requires two steps: converting the entire document into numbers, the frequency count generator, and applying the Bayes theorem of that. And finally, it is to check the accuracy, whatever we did it for the machine learning thing, we can use all these metrics from the sklearn for calculating the accuracy, to generate the confusion matrix, to generate the precision and recall values. We can use all these functions which are available in the sklearn metrics library. Yeah, precision score and recall score it is. So more about this precision, recall, and the accuracy confusion matrix, I'll tell you in the next video, where we will consider in detail that how confusion matrix is generated, what will be the size of confusion matrix, what is precision, what is recall, how to compute, how to cross check about the labels it is. All these things will be told in the next video. This is all about naive Bayes text classifier, which is based on the Bayes theorem, which uses the prior probability and the conditional probability to calculate the posterior probability. Thank you very much for listening.